What's up guys, my name is Preston Palmer with Student Engineering, and in this video we're going over an example problem on how to solve for a moment. If you find this helpful, please subscribe. So what we have here is a pipe that comes up 3 feet, over 4 feet, and over the other direction 5 feet, and we've set up our coordinate system where Z is up and Y and X are in these directions. And we have two forces pulling on the end of this pipe, each represented by these vectors, and they're in units of pounds. I ran out of room on that side, but they're in units of pounds, and we're using units of feet for the length of the pipe. So what we need to do is we need to determine the moment produced by these two forces at this point O, which is our origin of our coordinate system. So what we need to do first is we need to find our moment arm that is between our point that we're trying to find the moment of and our forces. And the way we'll do that is we'll represent it as a vector, and it's pretty easy in this case because the pipe, the measurements of the pipe make up the measurements of our moment arm. And so we have it going 4 feet in the X direction, 5 feet in the Y direction, and 3 feet in the Z direction. So we can write that as that our moment arm, we'll call it R, in vector form, that's going to be 4I plus 5J plus 3K. So now that we've got our moment arm in vector form, we're going to want to add up our two forces so that we can take the cross product of our moment arm and just one force, and that way we can find the magnitude of the moment about point O. And so we will add these two up by just adding up their components because they're in vector form, and so our resultant force, we'll call it sub R, is equal to our force 1 plus force 2, and that equals 100 plus negative 200, that will be negative 100I, and negative 120 plus 250, that will be plus 130J, and then 75 plus 100 plus 175K. So this is our resultant force when we add up force 1 and force 2, and so this is the force acting on the edge of the pipe. So what we're going to do is we're going to take a cross product of our vector R, our moment arm, and our resultant force, and that's going to look like R cross F sub R will equal the determinant, the I, J, and K directions. Our R vector is 4, 5, 3, and our force vector is negative 100, 130, and 175. And so that's our determinant. If you don't remember how to solve a determinant, you can click on this link and that will take you to my video explaining the cross product. But what we'll do is for our I component, we're going to cross out this row and this column. We're going to multiply 5 by 175 minus 3 times by 130. So 5 times by 175 minus 3 times by 130, and that's in our I direction. So we're going to minus our J component. We're going to cross out this row and this column. We're going to do 4 times by 175 minus 3 times by negative 100. And that's in our J direction. And then plus our K component. Cross out this row and this column. And we'll do, this row and this column. do 4 times by 130 minus 5 times by negative 100. 4 times by 130 minus 5 times by negative 100. And that's our K component. And so you'll do the math, set these up, and I'm just going to skip a few steps, and you end up getting that our moment about 0.0 is going to equal 485I minus 1000 J plus 1000 20K. And so this is our moment in vector form. If we want to just find the magnitude of the moment, we can do the square root of the sum of the squares, and I'm just going to give that to you. You do the square root of 485 squared plus negative 1000 squared plus 1020 squared, and that moment equals 1508 pound-feet. If we want to simplify that, 1,000 pounds is a kip, and so that would be 1.5 kip feet. Alright guys, so that's how you solve for your moment about 0.0. We took the cross product of our moment arm and our resultant force vector, and we got our moment in vector form. And we also took the square root of the sum of the squares to find the magnitude of our moment. And that is how you solve for the moment about a point. Alright guys, that's it for this video. If you found it helpful, hit that like button, share this channel with your classmates, and if you have any questions or suggestions, leave them down in the comments below, and don't forget to subscribe.